In this video, we're going to talk about every different type of area you can be asked to find in normal curve problems and strategies for how to find these areas using the z-table. There are only a finite number of ways you can be asked to find sections of area under the normal curve. Just remember, your specific z-table gives sections of area between 0 and a positive z-score. This is the first type of area we'll look at. So when you need to find the area between 0 and a positive z-score, which is what we have over here, you just need to look up the z-score on the z-table. This is just the way our z-table is set up. When you need to find the area between a negative z-score and 0, like we have over here, because the curve is symmetrical about the mean, you can look up the positive version of that z-score on the table. So these two pieces of area are the same because the normal curve is totally symmetrical. So if you have to find the area between 0 and a positive z-score, or 0 and that same negative z-score, it's the same thing. You would just look up the positive version of that. So let's say this was negative 1.5, you would just look up positive 1.5 on the table, and these pieces of area would be the same. This is the easiest type of area you can have to find using your tables. This is another type of area we can have to find, where you have to find the area between a negative z-score and a positive one. When you need to find the area between a negative z-score, or one that's below the mean, and a positive z-score, one that's above the mean, you would look up both z-scores on the table and add the areas together. So we can split this section of area up into two pieces that we can look up on the table. We can look up the area between 0 and a, right? But a is going to be negative, so you would have to remember look up the positive version of a, since it's below the mean, and you can look up the area between 0 and b. Then when you put these two pieces of area together, right, the area from a goes over here, and we would look up the area from b next. Then when you add the two together, you have the full piece of area they want you to find. This is another type of area they can ask us to find. When you need to find the area above a negative z-score, like we have here, or when you need to find the area below a positive z-score, like we have over here, you would look up the positive version of the z-score on the table, and then add that area to 0.5. We can do this because the curve is symmetrical and each half has an area of 0.5. So don't forget this, that each half of the normal curve has an area of 0.5 because the total area underneath the curve is equal to 1. So this piece over here would be 0.5, this piece over here would be 0.5, and also these two areas would be the same, again because the curve is totally symmetrical. The only piece of area that you would need to look up here is the area between 0 and negative a, or the area between 0 and positive a. You add those two pieces together and you end up getting the full amount of area. Now we'll look at another type of area. When you need to find the area below a negative z-score, like we have over here, or above a positive z-score, like we have over here, look up the positive version of the z-score on the table and subtract the area you get from 0.5. So what we're going to look up on the table is this piece of area over here, and then you're going to subtract this from 0.5, so you're left with the shaded area that you want to find. So remember, this full half over here is always going to be equal to 0.5. Whenever you're dealing with an entire half of area above the mean or below the mean, it's equal to 0.5. And we can look up the area between 0 and negative a, or we can look up the area between 0 and positive a, subtract that from 0.5, and then you're left with this shaded tail end. Next type of area they can ask us to find. When you need to find the area between two positive z-scores or between two negative z-scores, look up both z-scores on the table and subtract the smaller area from the larger area. So here we want to find the area between positive a, positive b. Here we want to find the area between negative b, negative a. So what we would do here is you would look up both of these areas. The area between 0 and b is going to be the larger area, and then the area between 0 and a is the smaller area. So our smaller area is here, and I'll shade the corresponding area on this one. If we look up the full area between 0 and b, and we subtract this smaller area between 0 and a, what we're left with at the end is the shaded region that they wanted us to find. And we can do the same thing over here when we're dealing with two negative z-scores because the curve is totally symmetrical. we would shade, again, I'm shading this area between 0 and negative a. This is where it would fall over here. We can find the area between 0 and negative b, that's the larger area. Then we remove this piece that we looked up, and we're left with the shaded area. So to summarize what we talked about here, to know what type of area you need to find, you must draw a picture first, and you're required to draw a picture for these problems, even if you're using a calculator, which we'll get into later. After you draw your picture, you can figure out what type of area it is. Once you know what type of piece of area you're looking for, if the piece of area is touching the mean, you need to add. If the piece of area you need to find is not touching the mean, you need to subtract. So we'll go back here. Here we had a piece of area that was not touching the mean, the shaded area between a and b, or between negative b and negative a. Not touching the mean, here we had to subtract. In this example, we had a lower tail end or an upper tail end. This piece of area was not touching the mean, we had to subtract. Here we have a piece of area above a negative z-score, below a positive z-score. Notice how the mean touches this area. Here we had to add. Over here, we had the area between a and b, between a negative z-score and a positive z-score. Again, this area falls over the mean, or the area is touching the mean, so we had to add the values we looked up together. Over here, we don't need to add or subtract anything because this is just the type of area that the z-table you have gives you.